Hello. Mm, this is my first session streaming live. Today I'm going to read about the blog post, the things I wished I had known before studying YAML. I think this blog post will provide me some unique insight. Yeah, I'm also a YAML engineer, so I let's look into the different perspective of the different developer. Okay, now things I wish I had known before starting ML. It is part one. Means this blog post may be divided into different part. Okay, nice. Oh, she during much needed vacation on Mediterranean Sea, I found myself lying on beach, staring into waves. Lady Luck was having good day. The sun glared down the blue and cloudless sky, skating the sand and salty sea around me. For the first time in a while, I had a downtime. There was nothing related to Yamal in the remote region where I was, where the rough road were scared away. Who is used to even pavement of the Western countries? Then away from work and partially civilization, somewhere between the zoning out and full on dreaming, my thought began to drift. In our day to business, we are too well busy to spend doing nothing. But nothing is strong over here as my thoughts drifted. I recalled recent events, then pondered about work, then eventually arrived at machine learning. Maybe the traces of my articles when I reflected on 6.5 years of doing ML were lingering in the back of my mind. Or maybe it was simply a complete absence of anything technical around me, where the sea was only my companion. Whatever the reason was, I was mentally started rehearsing the years behind me. What had I what had gone well? What had gone sideways? And more importantly, what do I wish some had told me at the beginning? Okay, this is the starting. The post is a collection of the things. It is not meant to be a list of dumb mistakes that I urge others to avoid at all cost. Instead, it is my attempt to write down the things that will have made my journey a bit smoother. But only a bit. Uncertainty is necessary to make the future just that, the future. Part of my list overlap with my previous sports and for a good reason. Some lessons are worth repeating and reading again. Here is part 1 of the list. Part 2 is currently buried in the sandy sea water stained notebook. My plan is to follow up with it in a couple of weeks once I have enough run time to turn in into the quality article. Okay, it is just a rambling about how it came to it. First, doing YAML mostly means preparing data. This is one point. I try not to think too much about it, or it will tell me you did not do your homework. When I started out, my internal monologue was I I just want to do YAML. Whatever that means, I had a vision of plugging the neural network together, combining method, and running a large-scale training. While I did all of that at the one point or another, I found doing YAML more often means spending a lot of time just preparing the data so that you can eventually train the machine learning model. Yeah, this is so true. Model training, ironically, is often shortest and last part of the whole process. Yeah, data preparation is mostly one of the important part in any of the EML model training. Uh, it was much more of the thing in the past EML training. Yeah, just like the uh, regression training, logistic regression. Yeah, uh, what a random tree, XGBoost. Yeah, all the work algorithm where we used to train the traditional machine learning model, it was important to gather the data to find the features which were more in line with what we are trying to achieve, do different validation and different preprocessing and to make the data cleaner, different type of thing where most of the thing were related to the data. And the last part was the model training, which was to eventually get the result by using the clean data. But deep learning, during the deep learning, most of the feature extraction, manual feature extraction was gone away, because the job of feature extraction was also done by the model itself. But it is also a relevant part today also, because even though the most LLM are written in the unsupervised learning, that means there is no uh, uh, there is no manual data, manually crafted data when written, but we clean data, removing the coarse word, removing the inappropriate word during the pretending and fine tuning. This is in fine tuning, most of the data are the human curated, even though today LLM are generating data, human curated data is much preferred. But when we are working with the traditional ML, in most of the real world application, yeah, where there is a real-time prediction, and model have to be updated fast in weekly basis or daily basis. In most of the situation, there is people are using, people will use, and you are also using the traditional ML because it is fast to return it, and it is fast to inference, yeah, because billions of transaction or billions, millions of, what can I say, inference are being, prediction are being done in the real time, just like in the stock market prediction, yeah, and weather prediction forecasting. In this is since art of model, also we use the traditional machine learning model because it is small and fast to retain. It needs the online training, yeah. Okay, let's get into back to the article. Thus, every time I eventually get into the model training step, I mentally breathe a sigh of relief, because it means I have made it through the invisible part, the preparing data. There is nothing sellable in merely preparing data. In my experience, preparing data is not noticeable in any way. Yeah, if you are doing the ML, you know that preparing data is not noticeable to by the manager that you are working on, if they are not in the same tech field as you. Yeah. Here is the unusual pattern for it. Oh, I'm sorry. Here is the usual pattern for it. You have a project, you get the real world dataset. If you work with the well curated benchmark dataset, then you are lucky. You train the model, but first, data cleaning, fixing, merging, validating. Let me give you a personal example once I have told as a funny story, which it is now. Back then, it meant to redoing the few days of machine learning work under the time pressure. I once worked on the project where I wanted to predict the vegetation density using the NDPI index from ERA5 and weather data. ERA5 weather is a massive gridded data set freely available from European Center for Median Range Weather Forecast. I matched this dataset with NDPI satellite dataset from NOAA. Basically, the way American Weather Data Agency carefully aligned the resolution and everything seemed fine. No mismatches, no error were thrown. Then I called the data preparation done. Train the vision transformer model on the combined dataset. A few days later, I visualized the result and surprised, the model thought the earth was upside down. Literally, my input was right sided up, but the valid target dataset vegetation dataset was flipped at the equator. What happened? What had happened? A subtle bug in my resolution translation flipped the latitude orientation of the vegetation data. I hadn't noticed it because I was spending a lot of time on the data preparation already and wanted to get to the fun part quickly. This kind of mistake once and in an important point, a real world project are data projects. Especially outside the academic research, you are not working with CIFAR or ImageNet. You are working with messy, incomplete, partially labeled, multi-source dataset that require cleaning, aligning, normalizing, debugging, and visual quick inspection. And more, even more, data list is non-existent. Then repeating all of the above. Getting the data is right the work. Everything else is built on the sadly invisible foundation. That is so true because whenever we are training in any, when I'm doing in any project, if the code to fine tune the model, to train the model, and pretend weight, most of the models we use are in the are freely available in GitHub and Hugging Face. Yeah, codes are also training code are also readily available in the framework and in their own respective repo in most of the models. Yeah, but if our data is not clean and if our data is not uh, pre-processed, yeah, it's not good, uh, then the accuracy of the models drops, and the accuracy we try to need in the production environment becomes less. So it is important to note that we do the normalizing, and all kind of the processing in the data, aligning data, cleaning data, removing the unwanted data, redundant data. There are all kind of problem that get back to us, to haunt us when we completed the model training and when we try to inference on the unknown dataset. Yeah, so it is important for that data is the foundation of the machine learning model, and also the deep learning model. Yeah, yeah. Machine learning engineering means most of the work is done in data, but sadly now the machine learning ML engineer means the this putting together the OpenAI API and doing some RAG or using this other service to do RAG or some type of services that is only done by using the API and the prompt engineering. Yeah, fixing the prompt. Yeah. Okay. Now, writing the paper is like the preparing a sales pitch. Some people just write well. You might not be able to explain why. They have a flow, a logic, a clarity that hard to ignore. That really accident. For me, it turned out a writing paper resembled crafting a specific kind of sales pitch. You are selling your idea, your approach, your insight to an skeptical audience. This is surprising realization for me. When I started out, I assumed most of the work looked and felt the same. All of them were scientific writing to me, but over time, as I read more paper, I began to notice the difference. It's like that saying to the outsider, all ships look the same. To the shepherd, each one is distinct. For example, compare the two papers that I came across recently: a machine learning into the ML. In the top of the ML menu, which paper is this? Oh, construct contrastive learning for unsupervised adaptation of time series, and paper using YAML but published in top operation management journal. I think which paper is this? Addressing the distribution shift in the operation management, the case of order fulfillment in customized production. They are different. Both uses the machine learning. They speak, but they speak to different audience with a different level of abstraction, different narrative styles, and different motivation. The first one assumes that technical novelty is central. The second one focuses on relevance of the for the application. Obviously, there are there also is the visual difference between the two. The more paper you read, the more you will realize there is not only one way to write a good paper. There are many ways, and the ways varies different depending on the audience. And unless you are one of those very brilliant mind, think Terence Tao or somebody of that caliber, you will likely need support to write, especially when tailoring a paper to the specific conference or journal. In practice, that means working closely with a senior ML person who understands that field. Crafting a good paper is like a preparing the selfies. You need to frame the problem in the right way, understand your audience, that is target venue, emphasize the part that resonates most, and polish until that message is sticky. Yeah, that is the thing. I also noticed when I used to read a lot of YAML paper during my RL research and development work. That right now, when you are working in directly in the project, uh, you do not have most of the time and to read the sort of paper. Yeah. Bug fixing is the way around. Years ago, I had a romantic idea of YAML as exploring elegant model, inventing a new activation function, or crafting a clever loss function. That may be true for the small set of resources, but for me, the progress often looked like, why doesn't this code run? Or more frustrating, the code just ran a few seconds ago. Why does it no longer run now? Yeah. Let's say the project requires the Bayesian transformer on the environment satellite data. That is the model side of section 1 above. You have two options. Implement everything from the scratch, not recommended unless you are feeling particularly adventurous or you need to do it for some course credit. Find the existing implementation and adapt it. In 99% of the cases, option 2 is obvious choice, but just plug in your data almost never work out. You will run into the different compute environment. Assumption about the input safe, pre-processing works, such as data normalization, hard-coded dependency, of which I'm guilty too. Quickly, your day become the endless series of debugging, backtracking, testing edge cases, modifying data loader, checking GPU memory, rewriting script, then slowly then begins to work. Eventually, your model train, but it's not fast. It bug fixing way forward. 4. I very certainly won't make that footnote. You have heard of them. The transformer paper, the GANs, the stable diffusion. There are a small part of in my that thinks maybe I'll be the one to write the next transformative paper, and sure, someone has to, but statistically it probably won't me or you. Apologies, that finds. Yeah, it is very intensive work to get around the finding the new technique. Yeah, evolutionary technique that transfer the whole architecture, all the thought process in which we think how the models would work. Yeah, transformer is one type of an scale stable diffusion. Diffusion is also one of the technique that has again a new concept of thinking. Yeah, and that has evolutionarized the way in which we go to solve the problem of image generation. Yeah, and so it is quite complicated in the both mathematical sense because it needs the mathematics, the science, computer science, and uh, also need some sort of intuition of how it works. It is not built single-handedly. It is built upon the small step of idea, but majorly forward that prove to be a breakthrough in which all the other ideas were further polished. Just like the transformer is backbone of the current LLM, but most of the LLM did not use the encoder in transformer there was encoder and decoder, and encoder was stripped away, and only the most of the LLM are now decoder, because they did the research. They came with the idea, they uh, verified their approach in the smaller project, and it needed more resources also. So it is quite difficult for an ordinary individual to write the transformative paper, because it involves deep knowledge about that field. You have to get into deep knowledge about what you are doing. You have to also know the uh, theoretical basis of how are you doing it, even though it is not what can I say, it is not obvious in front of you. And most of the research paper are this transformative paper, like the GAN and diffusion paper, but they iterate on that idea, clearly trying to change it, and they try to uh, apply a different type of approach which worked previously in the different set of problem. They try to use that approach in the new version to try the different variation of it, and like this they get the more refined, and we get the more refined and refined version of it. So it is the gradual process, so it won't be me and you that is for sure. Yeah, I agree to the fact. The works that cause a field to change rapidly are exceptional by definition. Those works being exceptionally directly implies that most work, even good works, are barely recognized. Sometimes I still hope that one of my projects will blow up, but so far most did not. Some did not even get published. Hey, that's not the failure, it's the baseline. If you accept that every paper to be home run, then you are on the fast lane disappointment. Closing thought. Here is the closing thought of the author. To me, machine learning often appears as a slick, cutting-edge field, one where breakthroughs are just around the corner, and where the doing means a small part of the magic with the GPUs and math. But in my day-to-day work, it really like that. Most often, my day-to-day work consists of the handling messy dataset, debugging the code pulled from the GitHub, redrafting the paper over and over, not producing an over revision again. That's okay. Okay, it's the nice paper, and it most of we are all doing not to write the paper or publish paper. We are just doing to on the way on the ways to make the living. Yeah, and in most of the when you do the work in the cooperative environment, where most of the work is just like that. Handling the dataset and debugging the code from the GitHub. You are not writing the free scratch code from the scratch, because you are not doing the research. You are implementing the idea that has been proven to work. Because the company needs is the what company or business need is that what you do gets into the production that increase their revenue, not you trying your hard, spending months to write the code from the scratch, which is previously written by somebody else. So, so you are doing that a thing, and even if you are redrafting the paper, mostly the code um, in most of the paper there is some problem set that you are trying to solve, and there is a certain part of thing that you want to test. You only change the particular code. Yeah. Yeah, just like the what will happen if we replace that activation function relu with the gedu or other function, other activation function. Yeah, and what is the replace, how to we how do we change the uh, embedding function, yeah, to make the context length large. You are changing the small part of the code, and you are trying to get the result that may be better or worse, which is also a good finding, by the way, when you are doing the academic research, because it helps other to iterate on your idea also. Okay, this is for now, and thank you.